right, so not to call out Eduardo, but to call him out, he wrote down for mean and standard deviation. When I listen to this 5 years from now, it'll make me think of you, so it'll be a happy moment. All right. He wrote down the formulas that we used yesterday with the binomial distribution. Mean was n times p, and the standard deviation was the square root of n times p times q. And that's great that you know that, by the way, because that's not written anywhere. So that's awesome you know that. So shout out to you. Here's the downside of that, Eduardo. This is not a binomial situation, or at least not yet, right? It could become one. But to be binomial, it has to be a Bernoulli trial, which one of the components of a Bernoulli trial is only two options, success and a failure. So if it had said bringing 0 kids or bringing kids, then you could start to think that this was Bernoulli. But this says you could bring, or purchasing child tickets, you could purchase no child ticket, 1, 2, or even 3 tickets for a child. So the idea here is it cannot be binomial. All right. So I think actually this is the David moment. You're thinking too hard. All right. For this one. All right. I'm on fire today. So to do the mean, what's another word that if you were here yesterday with the Kahoot, what's another kind of vocab words that I've used to find the mean for a random variable? It's 2 words. One starts with an E. Somebody said it. Very good, Duran. The expected value. All right, so this, I hope you get one like this on the real AP exam, right? This is a real AP question. To find the expected value for C, notice what letter have I been using mostly? X, a capital letter X. Does it matter that this says C? No, they're telling you just to use capital letter C, right? You're going to multiply all of the different options. So 0 child tickets, 1, 2, 3 child tickets, times their respective probabilities. So 0 times 0.4 plus 1 times 0.3 plus 2 times 0.2 plus 3 times 0.1. All right, well, the first one's 0. Then it's 0.3. 2 times 0.2 is 0.4. So we have this going to get 0.7. 0.1 times 3 is 0.3. 0.7 plus 0.3, you're right, is 1 ticket. Now, in this problem, the statistic is actually a value that could happen, right? I could go up to the box office and buy 1 child ticket. What if this had been 1.2 or 0.9, right? Is that okay? Yes, it is okay. Statistics that are not actually values you could get are okay for your random variables. So don't think that it has to be 0, 1, 2, or 3, right? Most likely, I'll be honest, like that's usually not going to be the case. It's usually not going to be one of the values. Okay? All right, everybody good on finding the mean? This is the mean or the expected value. If you want to put the symbol, you can, right, for mu. Do you guys remember how to find the standard deviation? I tried on Tuesday to shout it at you, right? If you're going to find standard deviation, you best be finding what first? The variance. All right, so I'm going to find the variance first of this random variable. And here's the formula that I'm going to use, right? I'm going to do each of them, right? 0, 1, 2, 3, minus the mean. What did I just find was my expected value? 1, square that. Don't forget to square the difference. And then times its respective probability. So go back to the table. What's the likelihood someone's going to purchase no child tickets? 0.4. And just repeat that. Okay. Now I'm going to show you 2 things. Number 1 is I'm going to show you that I can type all that in and get my variance. All right, I'm going to do that right now. This is how I showed you to do it on Tuesday. All right, so my first one was 0 minus 1 squared. I did the wrong one? Okay. Times 0.4 plus, well, you know what? I think I did last time. I said I'm going to hit enter and then plus plus. Now, technically this one, do I need to type in the 1 minus 1 squared times 0.3? Right? It's not wrong if you do, but if you notice 1 minus 1 gives you 0. 0 squared is 0. 0 times 0.3 would be 0. So actually I'm going to skip that one. I want to be very clear, especially if you're watching this video, you're not in class right now. Okay? Am I saying that it's okay to just skip them? No, the reason it's okay to skip this one is because it would become 0. Right? If you're worried that like, oh, I might skip it when I shouldn't, just always type them all in. Right? Never wrong to type them all in. 2 minus 1 squared times 0.2 plus 3 minus 1 squared times 0.1. Okay, so we have 1. All right, and when I think about this, this is my what? This is my what? This is ticket squared. Very good, Eduardo. Right, so this is tickets squared. Do I want squared tickets? No, I want just what? Tickets. So the standard deviation for this random variable is the square root of 1. Well, hopefully you know the square root of 1, which is 1. So 1 ticket is the standard deviation. Guys, are you going to get the variance of being 1 very often? Probably not, right? We've done a lot of examples so far this week, and this is the first time that's happened. Are you going to get many that the mean and the standard deviation are the same? Right? It could happen, right? It did just happen, but just don't expect that, right? It's not likely to happen. So let me show you another thing about these calculators. So if you haven't turned it on yet, make sure you turn it on. Go to stat, hit stat, and then edit. So stat, edit. Excuse me. Excuse me. In the first column, I'm going to put all of the different possible values for my random variable C. So 0, hit enter, 1, 2, and 3. Right? Those are my 4 possible values for people going up to buy tickets for children. Go to list 2. Go over to the right to list 2. In this column, put the respective probabilities. So 0.4, 0.3, 0.2, and 0.1. Now, one of the first things I showed you guys with these calculators back in September was you can compute statistics. Right? Shouldn't surprise you. You're in a course called statistics. So let's compute some statistics. So hit stat and go over to calculate. So hit stat, over to calculate. Do you see the very first one? It says 1-var stats. That means one variable statistics. Our only variable right now, it's a random variable, but it is C, right? One variable. So hit enter on number 1. You see where it says list is list 1. I put mine on list 1, right? 0, 1, 2, 3, so we're good there. But you see where it says frequency list, frequency list. You see that? This is where you have a chance to tell the calculator, hey, is this a random variable? Will it take on different values? And the answer is yes. So if I hit second, so I'm going to hit second, and then number 2, which will give me list 2 there. So second, number 2. All right, and then I hit calculate. This will now calculate what I just did. All right, do you see X bar? X bar, I usually use Y bar, but X bar is the mean, right? And that says 1. What was our mean? 1 ticket. That confirms it. Do you see where it says sigma X? That's the standard deviation, right? This is the only time I would use sigma. I've taught you guys to always use SX, right? So in this case, you're using sigma, which is 1. So you get the answer there. The reason I don't teach this really at all is because you'll notice if you scroll down, does it give you the variance? Does it give you the variance? No, which is disappointing, all right? I wish it did, but it doesn't. So I like to make sure you know how to find the variance because you're going to see in B and C, we're going to need to know what to do with variances, okay? Now, if you want to find the variance, you should hopefully know by now that the variance is the standard deviation squared, right? So all I'd have to do is square 1, which in this case, 1 squared is 1. Not a big deal when it's a whole number. What I'm saying is it's going to have a rounded number. So when you square it, you're going to have the variance, but is it technically the variance? No, it's rounded. So I try to encourage you to find it like that. Any questions on A? I know that was a lot for like a pretty straightforward question, but I want to make sure you see all the different options. Okay, B. Now it's asking if we include another random variable for the number of adult tickets. So I'm going to call this random variable A for adult tickets. It tells us what is the mean or expected value of the number of adult tickets purchased by a single customer. It says it's 2 tickets. What does it say the standard deviation for the number of tickets purchased by a single customer for adults is? 1.2 tickets. All I'm doing is just kind of like taking the words and writing it out of what they're giving me. It wants us to find the mean, again, that's expected value, and standard deviation for the total number of adult and child tickets purchased by one customer. So I'll say that this is T, which is going to be A plus C. All right, so how do I find the expected value of T? What do I do to find the expected number of tickets total purchased by a single customer? We did this yesterday in the Kahoot. You add what? You're right, Julia. What do I add? You're thinking too hard. You add this mean, which was 2, to the one we just found earlier. What was our mean of the child tickets? Oh my goodness, we did it. So I'm going to add 2 tickets plus 1 ticket and get 3 tickets. How's everybody doing? Hopefully you're thinking, nice, that was super easy. Is this free? I'm sorry? This is free response, yes. We are writing. I'm currently writing. No, I mean like this right here is easy to see if I were reading it. You wrote mean and you wrote 1 ticket. You wrote standard deviation, you wrote 1 ticket. So. Sure. If it asks like, do you see how it just says like compute, just saying compute right now? If it said explain or justify, then I'm going to be writing, a sentence. Okay, now I'm going to find the standard deviation of T, right? Which means I'm adding them together. But this is where we're all going to mess this up. Like all of us got it all wrong, I think, yesterday on the Kahoot, right? I'm finding standard deviation, but I should be really thinking about doing what? Doing something with the variances. And I know I am adding, but if this had said find the difference, I would still be doing addition with the variances. So I need to add the variances. So I'm going to find the variance for this. All right. Now, what was the standard deviation for the number of child tickets purchased from part A? 1. Very good. So I'm going to do 1 squared. For that one is the child. Make sure you know this is the child. Okay. There it is. What is the standard deviation that they gave us for the number of adult tickets? 1.2. So I'm going to write 1. Oh, no, don't do this to me. My pen is blinking. I think I'm out of battery. No, you have to get a battery. Let's see if it'll come back. Oh, it came back. 1.2 squared. This is for the adults. So if I find out what 1 squared is, which I know what that is, that's 1. Do you guys know what 1.2 squared is? Nice, 1.44. So if you add that together, you get 2.44. Again, is this my answer? No, this is squared tickets or tickets squared. I don't want squared tickets. I want just tickets. So my standard deviation is going to be the square root of 2.44. Is it 1.56? Why did I say 2.44? 1.44. Come on, Douglas. Come on. 1.56. Well done. Okay, any questions on B? I'll be honest with you, most likely a question like this is going to be on the multiple choice, right? This is obviously it is a real free response question. I would love to get this one. I think you guys can all do this. But most likely they do this on the multiple choice. All right, you guys ready for C? Okay, now one step farther than this, right? We've gone from just purchasing the child tickets, looking at purchasing adult and child tickets at the same time. Now you can probably imagine where we're going. What's going to be the expected or mean cost of purchasing these tickets and the standard deviation of that cost? All right, so again, I think the first part, finding the mean, right, or expected value of the total is going to be the simplest one, okay? What is the expected number of child tickets from part A that we're going to purchase? From part A, the child tickets was 1, right? Wasn't it 1? Expected number of child tickets? Yeah, part A, all the way there. 1 ticket, right? And how much are the child tickets? $15. Get out of here. What is this show? Plus, how much are the adult tickets? 25. And how many are we expecting to purchase for the adults? How many? It told us in part B, right? 2 tickets. All right. So what's $15 plus $50? $65. You did it. That's the mean. Okay. Now here's the hard part. I want to find the standard deviation for this as well, right, in terms of money. But you know I'll be finding what first? The variance. All right. So let's find the variance. And you're going to see it's almost the same work, right? So I'm going to copy down that 1 squared and copy down that 1.2 squared. But notice I left some spaces. What did I leave spaces for? Somebody said it, the money, right? The dollars. So how much are the child tickets worth? 15. Now be careful here. What am I dealing with? Variances. I'm dealing with variances. And every time I've dealt with variances, I means I'm doing standard deviations that are squared. So when I write this 15, make sure you write that 15 is squared. So I'm dealing with squared dollars, right? My units is squared dollars. That's a mistake that I see constantly. Every year, students just forget that we're dealing with squares here with variances. So you got to square those constants as well. Okay, how much do the adult tickets cost? 25. Make sure you square that as well. So this is going to be, let's see, 15 squared, 225. 225. Don't you dare flash on me. I just gotta finish this video. You can do this. Come on, pen. They can't hear me in the video. 225 plus, I'm gonna need the calculator for this one. 25 squared times 1.2 squared. 900. Oh my gosh, Ben, you're killing me. 900. All right, remember these are in squared dollars. So what is that, 1125? Squared dollars. So to find my standard deviation, I'm going to take the square root of 1125. So the square root of 1125 is $33.54. All right, that is it.